Hello everybody, this is the webinar. Let's check that you can hear and you can see me. I hope you can. If any problems, just let me know. So we are recording it live. The webinar is number 47 about object-oriented programming. I'm actually quite surprised. I was checking the list of webinars which I've done over the last 3 or let me check, maybe 4 years. And that's a pretty long list. I started doing these webinars. Let me check when was the first one. Yeah, it was 4 years ago in April 2015, and that was not only about object-oriented programming, it was also about management. So the first like 10 webinars were about programming, object-oriented programming, and then I started to do management webinars, and then I switched back to only programming. So this is the webinar 47, and it's again about programming, but this time not only about object-oriented, but also mostly about aspect-oriented programming, AOP, which is quite interesting topic. I'm getting questions about it quite frequently, and I can tell you my story, how I got uh, acquainted with AOP and how I loved it first, and how I can't say hated it, but I stopped liking it after some time. So I found a blog post, my own blog post, which is, as you can see, 5 years old. So I wrote this blog post 5 years ago about about aspect-oriented programming. After I made some Java library for aspect-oriented programming, and I was using that Java library in all my projects, in many projects, and I was so happy about it. That was before I wrote the book Elegant Objects. That was before I wrote so many blog posts about object-oriented programming. So that was the time before Elegant Objects. So let me show you what I was so interested in and how it actually worked and how I like this aspect-oriented programming. So it on the surface for a programmer it looks like this. So take a look at this class. You have the method which does something, and then we attach the annotation. And because of this annotation, we run the code, and boom, we get the message in the log, the messages which are telling us some meta information about this method execution. Like here, the method was executed with these parameters, and it returned this result, and it took that amount of microseconds, and then another set of parameters, and again another execution time. As the blog post says, nice, isn't it, right? So it's really cool because I don't need to write all of this. I don't need to program this logging mechanism. All I do is just attach the annotation. And we are talking right now about Java. So all I do is just put the annotation to the method, and then this magic happens. Just all of a sudden, these log lines are coming from somewhere, and it just works. So I decided to split this webinar into two parts. The first part, I will explain you how it works. I will explain you the technical details as much as I can in the next 15 minutes. I'll just explain you what's going on under the hood inside that library, and how exactly it works, and basically what it is, aspect-oriented programming. And then the second part of the webinar, I'll tell you why it's bad, why we shouldn't do that. I mean, I will tell you why we should and why we shouldn't. There are pros and cons, like the description of the webinar says. Sometimes we need this, but in general, I think it's not a good practice. It's not a good idea in general. So I just I just gave you the spoiler, so now you know how I'm going to end. So I'm going to tell you in the end that even though this technique looks convenient, and it looks really yeah, convenient, that's the right word, but the overall design of your application will suffer if you use too much of this stuff. especially in Java. So let's jump to the technical implementation. So how it works, how this code, what's going on, why I just put the annotation and then the magic happens. You can, of course, read this blog post, but I will try to. I actually read it just when I was preparing for the webinar. I read it again because it's 5 years old, and I was surprised that I still remember how it works. So what happens is that basically there are two parts. There are two places where the code exists. The first place is the code which is our code, which we just created. And that's the main place where we put the annotation. So this is just an annotation which is which I don't even know what's the right name for it. That's probably cross-cutting or something. I'm not sure how it's called, and I can't find it anywhere in the article. So that's just a marker. Let's put it this way. It's a marker. It's an information of where of what needs to happen. That's just a marker. This annotation, this annotation is a so-called runtime annotation. So there are two types of annotations in Java. You most probably know. There's compile time annotation and runtime annotation. So compile time, it's like the one you know, the override. So the override, it's a compile time annotation. So you put it for the method, and then compiler does something about it, pays attention to the annotation, and compiles the code in a certain way. The runtime annotation, it's a different story. It's an annotation which is compiled together with your code, and it stays together with your code inside the bytecode. So the compiler compiles this annotation like this one, and it goes to the bytecode. So when the application starts working, then the reflection API, via the reflection API, it's possible to get the information about this annotation. So the annotation stays together with the code. So that's just a marker. That's the first place where we have the code. The second place is where the actual advice is located. The advice is the place where this logging actually happens. So there are two pieces. The first piece is our code. The second one is the where the advice is written. I can show you in a few minutes. I'll show you the code of that advice. It's pretty complicated piece of code. It's difficult. I mean, I can show you now, probably, to give you an idea of how complex it is. Yeah, I'll show you right away. So here's the library, and the actual library which does this logging. And here's the code. So for example, the one for the logging, it's called method logger, this one. So this is the second place where the code is, and that place is called the aspect. Yeah, there are two things. There's a aspect here. See? So you write some class. It doesn't even implement any interfaces. It doesn't extend anything. It's just a class which, with again a marker aspect, and inside this aspect we have a so-called around advice. The advice. So advice is actually the method which is marked with this around marker, and it does something inside. So we have two places. The first one says we need logging here. The second place says with these annotations that I'm probably the place which may help the first place to do that extra job. And to explain it with the details, look, we're saying that something blah blah blah, it's pretty cryptic language, but we're mentioning that annotation here. So we're saying that here in this second place, we are interested to intercept, that's the word, intercept something that happens there at the first place. Two places. And they compile together. So the compiler creates the bytecode of the first place and the bytecode of the second place. And then what happens is that an extra process, an extra procedure happens on top of the procedure of compiling your bytecode. It's called weaving. I hope I pronounce it right. It's called, aspect weaving. That's the word. So that's the process of. It's an extra tool. You need a tool for that, and that tool is called AspectJ. It's one of the tools for Java. I'm not even sure. I'm not sure any other tools exist for that. But AspectJ is the tool for Java, and actually AspectJ is the inventor of AOP. So aspect-oriented programming, to my knowledge, was invented by the authors of this library, and they created this library, they named it AspectJ, and then all other languages started to do something similar. But the concept was born in Java world, to my knowledge. So the weaving is when you run an extra tool which takes those two pieces, two places, the one which needs logging and the one that knows how to do the logging, and it does a few manipulations. I'll explain you right now what kind of manipulations, and it connects them together using these annotations. This weaving tool, this AspectJ compiler, it looks at these two places and says, okay, now I understand that this place which needs logging will actually get the logging from the second place, and it connects them together, and then you get, and then it returns you back a modified compiled binary code. So you produce your original compiler, your Java compiler produces .class files, for example this .class, and then you run the weaver, and then you get another version of your class, another version of your bytecode. So the original code which was here, if you look at the bytecode after this manipulation, then you will see that you don't have this method anymore. Well, you have it, but it's different. So your code will be modified by the tool. So what exactly will be modified? How your code will work? You should look at this diagram. So I hope that you can understand this diagram. Well, I do. So if you don't explain, it should be easy. So the time on this diagram, the time goes from top till down, this way, and using these arrows, these so-called timelines, lanes. I don't know what's the right name for this. So these are the classes. There will be 4 classes instead of 1. So we had just one class, foo, where with the single method. And actually we had 2. We had these 2 places like we discussed. The first place is here. The second place is here. We had foo as a place where we need logging. And then we have method logger here, this one, which is the aspect, so-called. Aspect with the method, with the around advice. So remember the terms. The entire class is called aspect, and then the individual method is called advice, which is around advice in this case. There are 3 different types of advices. There are around advice, before advice, and after advice. Around means that we want to intercept the entire call for the method. What's the name of the method? The method name is power. So by the around advice, we want to intercept. We don't want to catch the. We don't want to intercept the control. We don't want to get the control only before the method is called or only after the method is finished. We want the entire control, before and after all together. That's why it's called around advice. You can read about it later if you're interested. It's not so important. What's important is that we had 2 places, now we have 4 pieces where something happens. So the call for the power method arrives to the original class, to the foo class, but it's not our method anymore. The method power was modified. It's not the method we had before. It's a different sum. So this Weaver replaced the method which we had with a new method, which doesn't do the calculation, but instead it calls the method logger and gives control to the second place. So the call arrives to the first place, and then the first place redirects control to the second place. The second place generates a joint point, so-called. So it's an object which knows what's going on. It's like a transfer object, so-called. But it's not exactly the data transfer object. It has some logic inside. So it's an object which encapsulates the situation. Let's put it this way. And then this object is being transferred to the method which they generated. So they moved our it's not the method they generated. It's an extra class which is generated by the Weaver, which returns control to us, to our original method, when we say so. So we say run, we actually say proceed. So this is proceed is called by us. So let me show you the code. So this is how our class will look, the original one. This is the power method, but it's not the original implementation. This is the original implementation. So our original method power was renamed to power underscore around body. And this is where our code is now. It was here, but now it's here. So we have 2 methods right now. And this one, when people who when clients don't know what's going on and they still keep calling this power method, they arrive here, and then we redirect this call. Not we, but this Weaver did that. We didn't do it manually. So the call gets redirected to the around advice of the aspect. It comes to us, we redirect it there, something happens there, and it comes back to us when necessary to here. So basically, you may understand, I'm thinking now whether you understand or not. This is the code of the advice. It's pretty large. It does all the logging. It's my code. I wrote it some time ago. It's quite complex. I mean, it took some time to implement that. And here's the main part, the most important part. It is wrap methods. Let's put it this way. So you see, so we arrive here when the method is annotated with this annotation. The execution arrives here. It gives us the preceding joint point, the one I mentioned. It's a transfer object, not exactly a transfer object, but it's an abstract of the situation. So they call it joint point. So they give us the place, they give us the control element, which knows where we stopped at the first place. And then we extract some method information from there. So from this point we can get the information of what happened. We get the information about the method, and then I say basically I extract more information to know exactly how logging should happen. And then I call this wrap. Here it is. There's some checks, something is going on, and then something is going on here, and let's see where exactly we call back. Look, this is the line we're interested in. So here we say, okay, now call us the original method. Make a call to the place where we started. I mean, to the place, the first place. and return back the result. That's how we return back to the original place. We execute the original method and we come back here, and then we calculate how much time it took, and then we do the actual logging here. So we print to the console the information about the execution time. So my point is that there are two places. One place doesn't know what happens. The second place is powerful and it knows what happens and it knows how to do the logging. It knows how to add the additional functionality to the first place. So here, the first place again, look, it doesn't want to know what happens. It doesn't want to implement logging. It doesn't want to repeat that large piece of functionality at the same place over and over again. So we just annotate our methods with this loggable, and thanks to this weaving procedure, we connect it to really large pieces of code which are somewhere and which do that execution for us. This is useful for a number of use cases. For example, if you take a look at this library, which I created 5 years ago, and which, it's 400 stars on GitHub, it's quite popular, and I use it I still use it actually, and I use it in a number of projects, and I find it quite useful. Look, it's been used by a few hundred projects. So there are a number of aspects which are, for example, loggable. We just discussed that. For example, quietly, that means that you annotate the method with this quietly annotation, and if any exceptions are coming out of the method, they will be just swallowed and ignored. Sometimes it could be useful. Sometimes it could be convenient when you don't want to catch them and just ignore. You just say, okay, whatever happens in this method, I just want to ignore everything from there, all the errors, all the exceptions. It could be useful. Or for example, asynchronous, async. Async means that you mark a method, and when the call comes to the method, once anyone calls that method, we immediately return the control back, but we start a new thread and execute that method in a new thread. Asynchronous execution. It's quite convenient as well. You just mark the method with this annotation, and you don't need to create your thread. You don't need to make sure the thread actually logs errors. You don't need to worry about anything, especially if you don't understand how threading, like multi-threading works, or if you just don't want to write all of that. You just put the annotation to the method, and the method works asynchronously on the background. It's quite convenient. Or, for example, the parallel. Parallel means that execute annotated method in multiple threads. That means that you put the annotation to the method, and then you say how many times in how many threads you want to execute the method. It's also sometimes convenient. For example, you I don't know, your method does pulls something from the pool, takes something from the pool, and then executes something with this, does something with its items, and you don't want to create a thread pool to add some job to the thread pool and then control that thread pool and then terminate the thread pool. You just say, okay, here's the method, run it in 15 threads. And then everything will be managed automatically by this library. For example, let's take a look how it's done, this parallel execution. Parallelizer, most probably it's here. I don't remember, it was like 2 years ago. And it's not even my code, as you can see. So that was created not by myself. So the parallelizer, look, that's the around advice. So when this parallel marker is found there, then we jump into this code and we do something here. Look, we start a new thread pool, as I told you, as I promised you, and then we add some jobs there, and then we make sure this thread is starting, and then we make sure this thread is shut down. So we control it. There's some code, etc., etc. So it's pretty large. Look, that's the code, which you know, quite long. And you don't want to write it over and over again. You just want it in one place, and you want it to work. So it is convenient. It is convenient for Java world, and it may look cool if you are a Java developer. I also thought so. That's why I created this library. That's why I made it all, because I started with the logging. I needed logging in so many places, and I was also, it was also quite, repetitive and routine job to make sure that my methods log something when they finish. And it's quite, sometimes you need that, and it's quite often when you, especially when you are not sure that the application works and you want to debug it somehow, you want to see more information in the logs, so you want to know which methods do what and how much time it takes for them to work, how long for how long they work, and you don't want to calculate it over and over again every method. So I created a library to make my life easier. However, and now I'm moving to the second part of the discussion. I hope I explained you how it works. So if you don't understand it still, if you need more details, then I will definitely give you the link to this blog post. It explains, I think, everything I know about aspect-oriented programming in just one simple example. It's not difficult. There's no rocket science there. It's really easy, just like I said, two pieces, weaving, the call jumps here, the call comes back. You can do it yourself as well. It's not so complicated. But now getting to the second part, why I think it's bad, why I think it's in general not a good practice. I actually think that that for Java world, it is a good practice in many places, like logging, for example. For Java world, I cannot imagine anything else. Why? Because Java is a language. It's a compilable language, and it's a strictly typed language. So it is impossible anyhow else to give programmers a freedom to modify any methods they want, to add functionality to any method they want in any particular class, the same type of functionality. I have an object, an object of some type, and there is a method, some method of that object, and then I want to add the functionality of logging to that method. There is no other way in Java to do that, unfortunately. In Ruby, in PHP, in Python, in JavaScript, there are ways. It is possible. I'm not a Python or JavaScript programmer in particular, but I know Ruby. So in Ruby, I can easily do that by using, I can even show you how I can do that. Let's take a look at the Ruby code. This is Java code, and I can show you the Ruby code. Maybe, I'll show you my library. I will not show you the code, I'll show you my library, which I also managed to create for a similar purpose. Which is a Ruby library. So again, let's think about the problem. The requirements are this. We have some object. We have some object of some class, and this object has a method. We cannot predict which object it's going to be. We cannot say anything upfront what's going to be the method of this object. We just know that one day we're going to have a class, we're going to have an object, and we're going to have a method, and then we will want to log everything. Not everything, but we're going to log the execution of the method. We're going to log the information about how that method was called, with which parameters, and what was the result of the method, and how much time it took. How we can do that without the information up front of what's going to be the type of this method? In Java, there is no way. In Java, the best way, of course, the right way, of course, the object-oriented way, of course, is to create a decorator. We have an object, we decorate this object with another object, and then the call arrives to the method. We do the logging, we do everything we want, then we call the original object, which is encapsulated, and then we return the result. That's the right way. That's the object-oriented way. You decorate and you add functionality. That's how you always extend your objects in object-oriented programming. You decorate them. That's the only right way to make objects more complex, to add functionality to objects, is to decorate them with larger objects. But in Java, when you decorate, you have to implement the same type, the same interface. So the object which is a decorator, it has to implement the same interface which is implemented by the object it encapsulates. But you cannot do that. You cannot create an object which knows how to log and implements all possible interfaces. It's just impossible. And that's why this aspect-oriented programming was created. So aspect-oriented programming is a workaround for the Java world. It's the only solution we may have in Java world, and unfortunately, the Java, the language, the Java as a language, over the last, I don't know how many years, let me check when was this Aspect-J was created. That was, I think, like maybe more than 10 years, that's for sure. Aspect-J was born, 18 years ago. 18 years ago, the problem was obvious, that we need some solution, that it's not possible in Java to decorate an object without, in a dynamic way. We can only decorate if we explicitly specify the type of the object we decorate, so we know explicitly what is the type inside. And there is no other way in Java as a language to do it otherwise. And that's why the Aspect-J was born. And over these 18 years, Java has not moved forward in this area. Not at all. Nothing was created to help us to get rid of this aspect-oriented programming, which is a workaround. So this workaround stays with us for 18 years. Nothing new was proposed by Java, unfortunately. In my book, actually, in Elegant Objects Volume 2, I have a section, 15 pages, where I propose the solution, how I think it would be better to design it the right way, without aspect-oriented programming. I have a section there about aspect-oriented programming in Elegant Objects Volume 2, and I have a proposal there, like how it can be done in Java, if Java would be modified a little bit as a language. But unfortunately, it's not happening with Java. Many other things are happening with Java. Java is, becoming the language with many more features, which, in my opinion, just making Java worse, instead of fixing that problem. The problem which doesn't make it possible to decorate easily, to make decoration more convenient for the dynamic situations. But in Ruby it's possible, because in Ruby the typing is not strict. So let me show you the library, the Ruby library, which I created, also my library, this library is not about logging. This library about making objects thread safe. So let's say you have an object and you have like a number of methods there, and then you want all of those methods all of a sudden become thread safe. So no matter what method you call, then all other calls to any other methods of this object will wait until that original call is finished. That's quite convenient. Sometimes you need it. For example, it's a class which it's an object which works with some sensitive resource, for example, a database which doesn't support multi-threading, or it works with some files which do not support multi-threading. So you don't want to write to those files at the same time from different threads. And that's why you design your object as a single-threaded object. And then you decorate it to make it thread safe. And again, you don't know what is going to be the object which you will decorate in the future. And you still want to have a decorator, and you don't want to use aspect-oriented programming. And in Ruby, you do it this way. And hold on, I just realized that I didn't tell you that why I think this AOP is bad, why it's not object-oriented. The key problem, probably I missed that, the key problem with aspect-oriented programming is that the functionality is not easily locatable, so not easily findable. So when you look at the object here, when you look at this code here, you look at it and you see the annotation, but then you have no idea, unless you are me, unless you are the implementer of this and you can easily find that code. But unless you are me, if you're just a programmer who is using this annotation, who is not the author of this annotation, then you will have no idea how it works. And you have no way of clicking making a single mouse click and getting to that code. So these two pieces of functionality, the two pieces which work together in the end, in production, in runtime, they are disconnected. You cannot go from the first piece to the second piece. It's just not possible at all, no matter how hard you try. Well, unless you investigate really the implementation of this library and go deep inside, and then you research and then you find out how it works, then you will know, okay, now I know who is paying attention to this annotation and what happens after weaving. And then you will understand that, okay, now I know that that particular round advice is actually looking at my annotation. Okay, I need to be looking here. That's not going to happen. This is exactly what Spring Framework is doing, or many other frameworks in Java. They are just splitting objects into parts, many parts, and it's not possible to put those pieces together back again for a programmer, for a regular programmer. Some people actually say that it's good. Sometimes I speak at software conferences and I tell them that it's so bad that in Spring Framework we have this really stupid classes like this one, who don't know anything about real execution, real code. All they know is just they put the annotation and then some magic will happen somewhere. So there's no control, no traceability. And many programmers actually tell me this is good. They just come to me and say, that's how we want it to be. We don't want to know what happens. We don't want to know how exactly logging happens. We just want it to happen. We just want to see the logs. So they feel that that Spring Framework is great because it simplifies the life of a programmer. And I do understand that. I do understand this argument. I think it makes sense if you are just a beginner, just a junior programmer who just starting and wants to create something fast, to deliver something immediately, and you don't really want to know how logging actually happens. You just want it to log, you just want to run your method asynchronously, or you want to run it in parallel, whatever. Just make it work. But when you grow as a professional, you actually face situations where you need to know, where you need control, where you want to control what's going on. And you can't. And you stay detached from the real code. You don't know what's under the hood of this machine, and you can only rely on some magic and rely on the proper implementation of that libraries, which is eventually will be quite difficult. So maybe for something really simple like this loggable, maybe okay, because logging is logging, it just logs. But even even in this case, if you look at the list of issues we have in this library, look, it's quite simple library, 54 unanswered questions, and I'm trying to answer them sometimes. But look how many times people ask me again and again, log performance issues, logging twice, logs not writing, something's not working as expected, not working. So they expect something to work, and they cannot really contribute the pull requests. 86 pull requests were contributed, and 100 issues. So people cannot really, most of those pull requests are mine, so ours. So we were developing the library, and those are our code. But people who write these issues, they really struggle to understand how that stuff works. And the only solution they have is just to get in here and submit a ticket and wait for the answer. And I try to answer them sometimes, but in most cases, I feel it that they just give up sometimes. Just it doesn't work, and I don't know how, I don't know what, I cannot even find the code. That's it. I'm doing something else. That's thanks for the aspect-oriented programming. It's a bad design. Aspect-oriented programming, it's a bad design decision, which was made a long time ago in Java because there is no other way in Java to do the decoration in a dynamic way. The decoration in Java is only possible when you know the type, the exact type of the object you decorate, and then you create another object of the same type, and that's how you decorate. So it's one-to-one, and that's it. You cannot create a decorator for many objects, for many different types. And this problem has not been solved in Java over the last 18 years, like I said. So let me show you how it works in Ruby. In Ruby, it's easier. In Ruby, look, this is my decorator. That's all. That's the entire code. To make any object, thread safe, no matter what's the type of the object. So first of all, it's a constructor. This is the constructor. So you encapsulate the original object. Boom, you encapsulated this. And then there is a special method, which is called method missing. This is the method which is provided by Ruby. It's a system method. It's a special method. So when any call arrives to this object, and this object implements just 1, 2, 3 methods. That's all. So I encapsulate your object, and then I catch everything that comes to me. It's called a catch-all method. So I catch all the calls. I intercept everything. And then here I first of all make it synchronized. And then I decide if the original object I encapsulate actually implements this method. Then I make a call. Otherwise, I do something. I basically I resort to I basically throw the call to the original, to the encapsulated method anyway. So no, it doesn't matter. It doesn't matter what's inside. Don't pay attention to the details. What's important is that I intercept everything, and that's all. So this decorator, this is the decorator. So this decorator can decorate anything, any type, and it can make any object thread safe. I cannot do the same in Java. That's it. That's why I need aspect-oriented programming. But so that's the situation. That's the reality. I do not recommend to do it, but if this is the only way, and in many cases it will be the only way, then you should do it. So that's probably all I wanted to say. So let me take a look at your questions. There's one question, decorate or compose? I'm not sure what compose means. I say just decorate. So I think that decorate is the way to call it. Yeah, there is some comment about the static methods, that we can use some static methods somewhere. I'm not sure about that, how static applies here. Yeah, it's a really good comment by someone saying that if you cannot resolve a problem with via decorator, it's not elegant. That's a perfect comment. I really like it. I'll tweet it. So if you cannot solve a problem in object-oriented software with a decorator, then your design is wrong. Everything should be decoratable, and everything should be, all the functionality should be extendable via decorators. If you cannot do that, then most probably your objects are mutable, most probably you're using some static methods, most probably you are yeah, I think there are two big problems: static methods and mutability. So if you have static, then you cannot decorate. If you have mutable objects, then most probably you will not be able to decorate. If you get rid of all of that, then all your objects will be immutable and there will be no static methods, and you will be able to easily decorate. And of course you need types, you need interfaces to in Java. In Ruby you don't need interfaces. There are no interfaces. In Ruby you can do whatever you want. It's quite loose language, so there are not so many restrictions, which make it sometimes very difficult to control the work of junior programmers. So the weaker the language, the easier to make mistakes. The stronger the language, like Java, it's more difficult to make mistakes, but we have this problem of aspect-oriented programming. Another question, can you show, the question sounds like, can you show us good example of decorating as a substitute of annotation? Well, most probably this example of Ruby is a good example. So here, without annotating, I am just doing the decoration. But in Java, I cannot show such an example, fortunately. Well, I can show you, well, most probably it's possible maybe, where people use annotations where they can use decoration, like they're the same type, but they use annotation. But I don't have that examples. No. Now there's another comment, some problems should be left unresolved. Maybe, but I think that Java really needs an improvement in this area. I don't know why we are getting, improvements in Java which nobody really, which I find anti-object oriented, like this many things. I'll probably be speaking at a software conference in a few months. I just announced it in my Telegram channel and on Twitter, and my presentation, my keynote speech actually, will be most probably about problems of Java evolution. So I think that Java evolves in the wrong direction. I think that we are making the language more and more ugly every year. With every next version, we're just accepting more and more garbage into the language, which doesn't make the language better. We are basically following the path of C++. We're just making the language worse and worse and worse, and the code quality just goes down, instead of improving the quality of code and restricting the features of the language. So this AOP is one of the great examples of how Java kills itself by not making decorating possible in a dynamic way. Annotation processors. Yeah, there's also a good comment that there are annotation processors which could do the weaving during the compile time. I agree with that. That's a really good comment. I thought about that. When I was creating this library, I didn't know about that. I was just not aware that that feature existed in Java. But Lombok, for example, Lombok library is doing exactly that. So Lombok is close to aspect-oriented programming. It does the same, actually, the same concept. Two pieces, they have to be connected. One piece is my code, another piece is coming from somewhere. Lombok provides that code, but they do the weaving in compile time. So it just you don't need two steps. With Aspect-J, you need to compile first, and then you do weaving. So there are two steps. With Lombok, with annotation processors, so-called in Java, this happens automatically by Java compiler. So this is better. I agree, that's better. But still the same concept for the programmer. We just don't know. You still cannot click the button and jump to the code which implements what you want to implement. Another question, what do you think about runtime bytecode generators instead of aspect-j? For example, creating a class in runtime to wrap some object. It's close to annotation processing. It's close because it will happen in compile time, or like there is in the chat people saying that it's happening even before compile, so it's a pre-compile time or in compile time. It doesn't matter. But for us as programmers, I don't really care about what's happening. I mean, I still don't see the code. For me, it's important to be able to look at my code, click the button or click two buttons, I don't know, and immediately jump to the place where I can see what happens. If I cannot do that, compile time, no compile time, it's a dark territory for me. It's difficult. So, like I said, annotation processing is better than aspect-j, of course, and this runtime code generation, bytecode generation, it's better because it makes my build faster. It's good for people who automate the build. Yes, for them, it's easier if everything stays together. Like annotation processing is easier than using two instruments. But in the end, for the programmer, it's still the same mess. So that's it. Thank you for listening. I hope I made that picture clearer for you, what I think about aspect-oriented programming. I was interested to a little bit, not to educate, but to demonstrate you how it works technically, and then you make your own decision. But now at least you understand what's going on behind the scenes. So you know that there are two pieces, they get connected, and these annotations are used for connecting them. Thanks for listening. Thanks for being with me today. See you next time. We try to organize these webinars every first Wednesday of every month at 11 in the morning Pacific time, American Pacific time. Thanks for listening. Stay tuned. Bye-bye.